Tech Nuggets, VLANs. VLANs. We're going to talk about virtual LANs today. When to use VLANs, why to use VLANs. We're going to go over kind of the details of VLANs and sort of the fiddly bits and Ethernet headers and things like that. We're going to talk about tagging and untagged. We're going to talk about access and trunk ports. I've got some diagrams, so we're going to kind of work our way through that. And at the end, I'll have a practical demonstration in a VM using Voios and some of the virtual switches in that to sort of demo how it works. So virtual LANs are a layer 2 construct. They are used to do network segmentation so that we can have different parts of the LAN separated. So if you were to use a packet sniffer or something like that, those packets would naturally be divided at a layer 2. So those ports on a switch that are set up to be used in one VLAN will only work in that port group. The traffic won't cross to another port unless it's part of that port group. Or we use a special feature called trunking, and we'll get into that. It's also used to do address summarization. So oftentimes we have a VLAN is a layer 2 construct for a variety of ports, and on top of that we layer a subnet. So sometimes they're synonymous, although in truth they are separate technologies. Many times we put those two together for sanity's sake as network engineers. We put those two together. It allows us to do some things that we couldn't have done before. IPv4 does not support quality of service, QoS, but with VLANs, we can give one VLAN a priority over another. So if we've got VoIP phones and they need a priority over regular, everyday traffic, we can put the phones in a special VLAN that the switches will give priority to because it's VoIP. It's not real QoS, but it's a hack at it, at least for IPv4. With other protocols like IPv6, QoS is built into it. We use it sometimes for security and network management. It allows us to understand how the ports are being used. We don't have to overlay multiple subnets on top of one VLAN. That can get real ugly for broadcast traffic and things like that. Sometimes it's nice to separate out those pesky developers that are good with packet sniffers from, say, your accounting people. You don't want those pesky network people or developers sniffing your accounting people traffic. Maybe they're, going to break in and figure out the accounting system. Although I find that hard to believe. Most developers don't care about accounting. Maybe if they're developing accounting software, maybe then. VLANs. VLANs are implemented using tagging. So each packet, as it enters a port, gets a tag. Even when we're not using VLAN tagging, it'll still get a tag within the switch. This tag is a 12-bit field in the Ethernet header. And that means we've got from 1 to 4,096 VLANs are available because that's how much you can get out of 12 bits. The default VLAN is 1. So if you're using no VLANs at all and your packets are going into a switch and they're running around inside the switch, they're probably on VLAN 1, which is the default VLAN. The standard for this is called 802.1q. We call it 1q or .1q. It has a couple different names depending on the product that you're going to see, so there'll be a couple different names that goes along. Tagging happens when a packet goes into a switch or into a port that understands tagging. And from there, it can be worked with and switched. Remember, it's not routed, it's switched based on, what its tag is. So if I have 5 ports in a switch and they're in a port group, and they all have the same VLAN associated with them, then other devices on those other ports will have LAN level connectivity to other devices in that port group. Like I said, static VLANs are set up on port groups. So when we go into different switches, sometimes they're GUI and sometimes they're not. And we sometimes work with VLANs in there. Oftentimes we're setting them up and using them as port groups, so we might have a 48-port switch that we've divided into 3 sections so that we can have, these going here and these going here, and, we can divide the devices that way. Instead of running physical uplink ports to each one of those port groups, we can use VLAN tagging to get the traffic out of the switch. And we're going to talk a little about that. And that's what an access port is, what you plug a device into. So your computer or maybe your wireless access point that is just kind of dumb will plug into an access point. The trunk ports are the special ports, and they're the ones that you usually have to go configure as a .1Q port or a trunk port, because they'll work with tag traffic. Access ports, when they release a packet out the access point, they pull the tag off. The tag won't show up when you sniff on the other side of an access port. When you sniff on the other side of a trunk port, all it knows is tag traffic. So a trunk port has to be plugged into a trunk port, or the other end won't know what to do with it. It'll see all these packets on weird VLANs and it'll throw them away because it says I'm on VLAN 1. Remember, that's the default VLAN tag. So two trunk ports will face each other and they'll pass tag traffic back and forth. And as long as the VLANs are defined on both sides in both switches, they'll pass them back and forth. And if the opposite switch has ports in that VLAN, it'll release the packets out there and switch it appropriately. It's a way of tying switches together so that you don't have to run multiple physical links for multiple port groups. There are devices that are smart enough to read tag traffic and write tag traffic. Routers are often the big winner in this. Instead of having to go jump through a switch that's configured appropriately, our router can be told, hey, this subnet is on this VLAN. When you go to read and write on this physical port, make sure you put the tag on it and it'll shove it out that way. And I'll have an example here. I've got a diagram coming up that's without any sort of routers or devices doing any tagging, and we'll talk about it a little bit, and then I'll show you another one that's got the router doing the tagging, and it sort of makes sense that we collapse the network a little bit. So as we look at our diagram here, you can see I've got the ISP at the top. It's got two connections to two different routers, Chris and John. Presumably they're running Voyos because that's what we'll see in the practical demo. And they're connected to a switch. Now, Chris and John and the ISP are all using access points. There's only one trunk link here, and that's between the two switches. And it's labeled .1Q trunk, and that's what's in purple. So the two switches are going to be communicating over one cable using tag traffic. So the access ports that Chris and John and Kelly and corporate web server are using are all access ports. But those ports have been configured on the two switches to know what VLAN they're supposed to be access points on. And that way when Kelly puts traffic out to the switch knows, hey, this should be in VLAN 1000, switch it appropriately. It'll go over the trunk port if it needs to get to Chris for wherever it's going. So it'll be able to pass traffic back and forth, but traffic that's for Kelly and a VLAN 1000 will never cross over into other parts of the switch, or should never cross over. There are, of course, security issues with leaky VLANs and things like that. But theoretically, it should never cross over to the other side. So I've drawn some clouds there to sort of show where VLAN 1000 and VLAN 2000 are, and nary the package should meet, except perhaps through a router. And in this case, the only way to get packets from Kelly to corporate web server would be go all the way up through our ISP, back down through John, back down through the same switch, and to corporate web server, which is quite tedious and lengthy just to get a packet from Kelly to corporate web server, which in theory, they're physically connected to the same switch. All right, for organizational purposes, we're going to talk about how devices can also put out tag traffic. So in this diagram, what we can see is I've collapsed the diagram. The ISP is talking directly to John. John is a Voyos router, and John can read and write tag traffic. It can be a trunk port to the switch. And in this way, layer 3 traffic will go from Kelly through the switch, which is layer 2, and up the trunk port to John. John's the router. John will route at a layer 3, rewrite the packet to come back down the trunk port, now as a VLAN 2000 packet on the correct subnet, layer 3 subnet, going to corporate web server. So in this way, we can have one big, fat, very fast pipe from John to the core switch, and the switch, which has multiple ports on it, physical ports on it, will be able to handle multiple port groups and VLANs, and John can handle that. This is, in fact, what we have in our lab, where we use a pfSense box to handle about 25 different VLANs and the routing and switching that goes with that. And we have to define each one of those VLANs in every device involved. So every switch, that's going to route VLAN 1000 and 2000 has to have the definitions, has to have the ports put in them. Of course, John in this case has to have it and has to be put in there. Up next, I'm going to show you a couple of the commands just so that we can have shown them to you. They look a little different than our other interface commands. Normally, we would set interface Ethernet 0, and we're used to just putting an address on it, and it goes out. In this case, VIF is a virtual interface. And it's going to tie it together, and we're going to see virtual interface 1000, virtual interface 2000. That's going to tell Voyos, hey, you're reading and writing tag traffic. You're no longer just putting packets on the wire, presumably in VLAN 1, but you're going to pay attention to tag traffic. After these two commands are run, it will only accept packets that are tagged for VLAN 1000 or 2000. If VLAN 3000 packets show up, it'll just throw them away because it says I don't have any definition for VLAN 3000. All right, we're going to go on to a practical demonstration. I'm going to do both diagrams in GNS3 so that we can kind of see it, work our way through it. I'll do a little packet sniffing so we can see where we would see the tags and where we won't see the tags as we go along. So I pre-created a bunch of the diagram that was already there. I've got two Voyoses, I've got two VPCSs, and a switch that's already configured. And if you go in and look at my switch configuration here for switch 2, you can see I've already pre-created it. I've got port 0 at VLAN 1. This is my trunk port at .1Q. I've got port 1 at VLAN 1000. It's an access point. Port 2. We're going to do the same thing on the other switch. So one of the things I learned the hard way was you cannot have anything attached to the switch when you go to configure it. So plop the switch out there and go edit it. The other thing I learned, and this is kind of an interesting interface, is that it's easier to just delete all of the ports and start over. So dial it down to port 0, set it for a .1Q port. There we go. We got it. And port 1, we're going to set up as a VLAN 1000 access point. And port 2, we're going to set up as a 2000 access port. And we're done. We can hit apply, hit cancel, should work fine. All right, so we'll go connect everything up. Right, Voyos 1. This is our trunk port, right? So we connect it to our trunk port. And Voyos 1 is VLAN 1000. Ethernet 1. 2000. And we should be ready to go. We'll start all this and I'll do a little time compression so we don't have to watch everything boot. All right, so I've got our two VPCSs here, PC1 and PC2, that are set up and ready to go. And they're connected on their respective, VLANs. So we'll do DHCP, and we'll do DHCP. And our Voyoses are set up, right? They've got DHCP servers running and NATs and all that kind of good stuff. I did all that earlier. And so we should be able to do things like that. They'll ping and let us out. And we can do that down here where they'll ping and they'll let us out. So we can prove connectivity. But how does that work here? Well, let's go start a capture and we'll see how that works. And we can see the tag traffic go back and forth as it goes along. So we should be able to see that. And there we go. There's PC1. Ping, 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 ping. And we can see right here it's got a virtual, there's our ID. There's 1000. And that's for PC1, which should be on VLAN 1000. And we can also do the same thing. And we're kind of going to the same place, so why don't we pick somewhere else? Maybe it'll be a little easier, right? This isn't doing any kind of encryption or anything like that. All it's doing is VLAN tagging. So I picked a different destination. That way it wouldn't be quite so confusing. 98, 138, and we can see it down here. And when we click on it, we can see we're on VLAN 2000. So the switch has gone and separated that traffic. And we're watching it go through here on the .1Q trunk port. But it's gained the tag. Now, when it comes out either side, it goes out an access port, so it strips the tag. So if you sniff here, you won't see it. You won't see the tag. It'll pull it right off. In the next demonstration I show, I'm going to go through and replace our upper part here with Voyos that will be able to read and write tag traffic, and that way we'll be able to have one machine with multiple interfaces that can do VLAN tagging and that kind of stuff. Normally we would use that as a trunk connection to allow it to do layer 3 routing with a great big switch that can do switch speed between the ports, and that allows us to get more ports cheaper. And I'll be back with that in just a minute. All right, so you can see here I've recreated our diagram. I've got the cloud, which does DHCP to Voyos's WAN side, which is ETH0, and off of ETH1, I've set up a link to our switch, which has 2 VPCSs, and each one of those is on a different Ethernet port. And if we look at the switch port, we can see I've got a trunk port on port 0. I've got VLAN 1000 on port 1 and VLAN 2000 on port 2, which is what we saw before. Ports 1 and 2 are access points. Port 0 is a .1Q port, which is a trunk port. So what we're going to do is configure Voyos 1 to be able to communicate via tagged ports. And so that way we don't have to have a switch between Voyos and the switch. We can talk directly from the router to the switch using tag packets. And to do that, we're going to set up the interface in a certainly special way. And ETH1, and we're going to say VIF, which is virtual interface 1000, and the address, which in our case is 50.254/24. And for the second one, also ETH1, VIF 2000, and we're going to set up 172.28.1.254/24. Commit it. And occasionally, I have pre-configured on here. If you go look, you'll see in here when we look at our config now, you can see that on ETH1 we see VIF 1000 and 2000, which is what we configured. You'll also look, if you look a little farther down, that I've already pre-configured NATs and DHCPs for both sides that are already set up and doing their thing. So unfortunately, you have to configure the NIC before you configure NAT and DHCP, or it requires that you bounce the router, which is what I'm going to do now. So I'll pause it real quick and I'll bounce the router, and when it comes back, everything will work. Because if we were to try it now, I sort of jerk the carpet out from underneath DHCP and NAT, and it gets very hostile about that kind of thing. So we have to reboot the router. So be right back. Okay, so we're back. It takes about 1.5 minutes for Voyos to reboot. So I figured I wouldn't bore you to death with me talking while that happens. So you can see here we've got both of our interfaces are up and configured and ready to go. NAT and DHCP and all that kind of stuff are configured here. And the NAT and DHCP configure, because it's all done on IP addresses, the only real difference is in the Ethernet card configuration, that VIF piece of the set interface. So let's go off to our 2 VPCSs, and we'll type DHCP, and DHCP, and we can see they're out there doring away, getting IP addresses. So there we go. One shows up in one, the other shows up in the other. We'll give it a little sniff here, and that way we can see what's going on, and we'll be able to watch everything that happens in between. So we can ping. We'll ping Google, and we'll ping Yahoo. Gives a different IP address, and we'll be able to see pretty much the same thing we saw before, which is that, pull that down a little bit, and we can see the 802.1Q and 1000 here, and pings back and forth, 2000. That's kind of what we expect to see, right? We expect to see the same thing. In this case, we don't have the intervening switch in the way. It's going to do all the work. Voyos is going to be able to translate and tag and untag and work with that kind of stuff, which saves us the effort of having to have multiple physical interfaces for each individual VLAN or subnet if they're sort of co-located on top of each other to do that kind of stuff. We only need one port in Voyos. To be a router, and an effective router, we can deal with 4,000 VLANs in one port. And to be a router, that means we only need 2 physical ports, right? One to WAN and another one to our internal that's doing tagged. And we can do up to 4,000 internal LANs and 1 WAN off a different interface, and we're an effective router at that point. So at that point, we don't need quite so much physicality to our our Ethernet interfaces. We can focus on making both our internal and external interfaces very high speed, 10 gig, 40 gig, fiber, whatever's going to make it the most capacity that we can get, because we can get the diversity at layer 2 by using VLANs and VLAN tagging. Well, I hope you've enjoyed our latest Tech Nugget on VLANs and VLAN tagging, and hope to see you next time for the next Tech Nugget.